Hey, today we're going to talk about 4.9, El Nino and La Nina. Take a moment, check out the enduring understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. Alright, so El Nino and La Nina are two events that occur around Christmas time. And the reason they are called El Nino and La Nina is because the fishermen were noticing something was happening around Christmas, that they weren't really getting a lot of fish some years. So they called this phenomenon El Nino. And the official term is the El Nino Southern Oscillation, which is right in here in the learning objective. But it might be, you might see it called ENSO, E-N-S-O as well. That's just the abbreviation. But typically El Nino, La Nina. So what I want to point out is that we have, like I told you before, we have warm shallow currents and we have cold deep currents that are flowing in the ocean. And one thing that this is kind of in jeopardy because of, differing global warming, climate change. There may be impacting global ocean currents. However, this flows around the planet. These warm shallow currents are flowing. This is part of the North Atlantic current. Then it cools as it gets into higher latitudes, sinks, and then flows basically at the bottom of the ocean, and it's saltier water. And then it gets over here, starts warming as it flows through other parts of the ocean, rises up. This is again called upwelling, and then this warm shallow current flows throughout the earth again. Now, you don't really have to understand the path of this thermohaline circulation. Just understand that there are surface currents and that there are deep currents. Now, in a normal year, we have these trade winds. This is South America. This is the western coast of South America. Don't just say South America. This is the western Pacific or the Philippines. This is Indonesia, the eastern coast of Australia. But at the equator, we have these trade winds. And these trade winds are blowing normal winds, and they're blowing all this warm water, building it up over near in the western Pacific, the eastern Philippines, Indonesia, eastern coast of Australia. And alongside with it comes this upwelling. So during a normal year, we have normal currents, and that's because these trade winds are blowing west. That means the warm water is flowing west, and we have upwelling in South America. Okay, and with the upwelling comes all of the nutrients from the bottom of the ocean, because when everything dies, it sinks to the bottom. All of those nutrients are present in the bottom. Coming up, it's very, very nutrient-rich waters in a normal year during this time around the holidays. So there's a lot of fish that live there. So again, in a normal year, this is another way of thinking about it. This is now from the side. This is the western coast of South America. This is what's happening to the air currents. Now this is the water. The warm is red. The blue is cool. This is from a side view. Okay? So the trade winds are blowing the equatorial water west. We have upwelling on the western coast of South America. We have the warm current bringing heat and precipitation to Australia and Southeast Asia. So with this warm water comes added precipitation during a normal year. We have high pressure in the East Pacific. So that's meaning that we're having the air is falling because we have all this more dense air is falling down towards the ground. And we have low pressure in the West Pacific. That's a normal year. Now during an El Nino event, notice it's going different. The water looks like it's going the opposite direction. So during an El Nino event, we have weakened or reversed trade winds. That means this warm water is going to slosh back to the east. Normally it blew all the way west, and then it's just going to flow back to the east. Notice there is no upwelling, so the upwelling is affected. So along with the no upwelling, there is a limit in the amount of fish or nutrients that are available to the fish. So the humans are impacted by reduced food intake, and because of no fish or a lot less fish during these El Nino years. Now I also noticed that we have warmer weather in Australia and it's going to be drier, and we're going to have a warmer winter in North America. Okay, we're also going to have increased evaporation when the water sloshes east and that's going to bring with it heavy rains. So more evaporation, because this warm water means more evaporation. We could have heavy rains, erosion, as well as property damage. So we run the risk of getting damage or seeing the impacts of this on the western coast of South and North America. So again, during an El Nino event, if you notice, we got all sorts of messes happening with these weather patterns. Okay, so now I have an accumulation of warm water in the eastern Pacific along the western coast of South America. So the trade winds are weakened and then blow east. We have no upwelling, it's suppressed on the western South American coast. The warm current is bringing with it heat and precipitation to North America and South America. And we have low pressure. We have low pressure in the eastern Pacific because this air is rising. And we have high pressure in the western Pacific. With this high pressure, we have a lot cooler waters as well. And it's going to be, you're going to see that there's going to be less rain. It's going to be drier and cooler than normal. During a La Nina year, so if you notice, during a La Nina year, this upwelling looks like it's a lot more. This looks like it's basically just a normal year elevated. So we have stronger trade winds. The trade winds are blowing exceptionally strong. Notice all this warm water accumulating in the western Pacific. We have a lot of upwelling over here. So the warmer water is flowing west, which brings the colder water is coming from the east or into the East Pacific, bringing with it a lot of upwelling. In fact, I could have had 2 arrows here because it's a lot extra upwelling, which brings with it more productivity. So there's going to be less evaporation because the water is much cooler, which is going to mean that there's going to be less rain. So we'll have a dry, warmer winter, but then it's going to be more rain in the Pacific Northwest. Because this is drier, this is also going to be wetter in the Pacific Northwest. So during a La Nina year, people in Seattle, people in British Columbia and southern Alaska are maybe concerned for rain damage. This is another way of looking at it. We have stronger trade winds. It looks like the first example with the normal year. But if you notice, this upwelling is much, much stronger. So stronger than normal trade winds are blowing west. We also have greater upwelling on the western coast of South America. We have a warmer and rainier time in Southeast Asia and Australia. It's going to be way, way warmer and way wetter. And these are the impacts that you're going to see. So what you're seeing here is a comparison between an El Nino year and a La Nina year. So I have red representing El Nino, blue is going to represent La Nina, and then in this map, the blue and the red just represent different temperatures of water. So in an El Nino year, we're going to have warm water building up in the eastern Pacific. So you'll just see what's happening to the water temperatures. Okay, so the blue and the red don't necessarily correspond to the map. They correspond with El Nino, and blue is La Nina. So in an El Nino year, you're going to have decreased upwelling in western coast of South America, in the eastern Pacific. And in the La Nina year, you're going to have increased upwelling, which means better fisheries. In an El Nino year, the North American winters will be warmer with a little bit more flooding in the west coast of the Americas. And that's because we have all this precipitation building up. Precipitation is happening here because there's a lot more evaporation with these warmer waters. Now, on the contrary, when you have the cooler water moving, or the warmer water moving west, you're left with cooler water over here. You will have cooler and drier weather in the Americas because there will be less evaporation. But the tornado activity will be stronger because you're going to have more warmer air coming from the west, so it'll impact the atmospheric circulation. In an El Nino year, you'll have less Atlantic hurricane activity, which is not really shown here. Now this is something you should just remember. During El Nino years, there's fewer Atlantic hurricanes. During a La Nina year, there is more Atlantic hurricanes. And I'm not 100% sure at the time that I'm recording this. I mean, I could easily look this up, but I imagine you're having all the warm water sloshing to the west, which means you're going to have it the warm water on the opposite side in the Atlantic Ocean is probably going to be flowing a little bit more to the west, which brings with it a lot more hurricane potential. In an El Nino year, you will have droughts in Southeast Asia and in Australia, and you'll have less monsoon activity in India and Southeast Asia. And monsoons are just the seasonal rain periods. And in a La Nina year, you will have rainier, warmer, increased monsoons in Southeast Asia, because notice they're getting a lot of warm air and a lot of warm water. That's going to have a lot more evaporation, more precipitation. All right, for your FRQ practice, I would like you to describe 2 environmental problems associated with El Nino effects. I hope that this was informative. I hope you took away the key points. We will get some practice at this, and I thank you for your attention. I will see you soon.